12,000 years ago, the Earth looked nothing like it does today. That a sheet of ice 2 miles thick covered everything from where New York City now stands to the edge of the Arctic. Sea levels were 120 meters lower than they are now. The English Channel did not exist. You could walk from Britain to France. You could walk from Siberia to Alaska. Then, in what geologists describe as an eye blink of time, it ended. The ice retreated. The seas rose. Ecosystems that had been frozen in place for 100,000 years restructured themselves across every continent. Forests replaced tundra. Deserts replaced grasslands. Coastlines shifted hundreds of kilometers. And the humans who had survived the ice, a population some researchers estimate at fewer than 100,000 people worldwide, found themselves inheriting a transformed planet. What ended the Ice Age? The answer is not what most people expect. It is not a volcanic eruption. It is not a meteor. It is not gradual atmospheric change. It is something far more precise, far more mathematical, and far more unsettling. Because the same mechanism that ended the last ice age is running right now. To understand what ended the ice age, you first have to understand what caused it. The Earth does not travel around the sun in a perfect circle. Its orbit is an ellipse, and that ellipse changes shape over time. It stretches and contracts on a cycle of approximately 100,000 years. At the same time, the Earth's axial tilt, the angle at which the planet leans relative to its orbit, wobbles between 22 and 24.5 degrees on a cycle of approximately 41,000 years, and the Earth wobbles like a spinning top on a third cycle, called axial precession, completing one full wobble approximately every 26,000 years. These three cycles, orbital eccentricity, axial tilt, and axial precession, interact with each other in complex ways. When they align in certain combinations, the amount of solar energy reaching the Northern Hemisphere in summer increases significantly. When they align in other combinations, summer sunlight in the Northern Hemisphere decreases. This is the Milankovitch cycle, named after Serbian mathematician Milutin Milanković, who calculated the full theory between 1912 and 1941 without a computer, working entirely by hand. Here is why the Northern Hemisphere specifically matters. Ice ages are not caused by the planet getting colder overall. They are caused by summers in the Northern Hemisphere getting slightly cooler. Why does that matter? Because the Northern Hemisphere contains most of the planet's landmass, and land-based ice sheets, the kind that covered Canada, Scandinavia, and northern Eurasia, can only grow if summer temperatures are cool enough that winter snow does not fully melt before the next winter arrives. If summers are slightly cooler, some of last year's snow survives. The following winter adds more snow on top. Over centuries, this accumulates. The ice sheet grows. As it grows, it reflects more sunlight back into space, a process called ice-albedo feedback, which cools the planet further, which grows more ice, which reflects more sunlight. The cycle locks itself in place, and then the Milankovitch cycle shifts. Approximately 20,000 years ago, the ice sheets reached their maximum extent, what geologists call the last glacial maximum, and then, slowly, the orbital geometry began to shift toward a configuration that increased summer sunlight in the Northern Hemisphere. The summers grew marginally warmer. Not dramatically, not overnight, by perhaps 1 or 2 degrees over centuries. But that was enough that if summers are slightly warmer, more winter snow melts before the next winter arrives. The ice sheets stop growing. They begin, very gradually, to retreat. As they retreat, they expose darker land and ocean beneath. Dark surfaces absorb more sunlight than ice. The planet warms further. More ice melts. The feedback that had locked the planet into ice for 100,000 years now ran in reverse. And once it began, it could not stop. But here is where the story gets more complicated. The Milankovitch cycle explains when ice ages begin and end. It does not fully explain the speed. The transition from peak glaciation to the warm interglacial period we live in now took approximately 10,000 years. That is fast by geological standards. Geologists have found evidence that some of the most dramatic warming happened not gradually, but in pulses, rapid events in which global temperatures shifted by several degrees within centuries or even decades. One of these events is called the Balling-Allerod warming, which began approximately 14,700 years ago. In what appears to be less than a century, temperatures in Greenland rose by approximately 10 degrees in less than a century. That kind of speed cannot be explained by orbital mechanics alone. Something else amplified the warming. The amplifying mechanism was carbon dioxide. As the planet warmed, the deep oceans, which had stored enormous quantities of carbon dioxide during the cold period, began releasing it into the atmosphere. More atmospheric carbon dioxide trapped more heat. More heat released more carbon dioxide from the ocean. Another feedback loop, running in the same direction as the ice-albedo feedback. And there was a third amplifier as ice sheets melted. Enormous volumes of fresh water flooded into the North Atlantic Ocean. This disrupted the thermohaline circulation, the deep ocean current system that transports heat from the tropics toward the poles. When the circulation weakened, heat redistribution across the planet changed dramatically. These disruptions did not cause uniform warming. They caused regional chaos. Rapid warmings followed by rapid coolings, shifts in monsoon patterns, droughts in some areas and floods in others. The end of the Ice Age was not a peaceful thaw. It was a planetary convulsion. What did this mean for the humans living through it? Consider the timeline. At the last glacial maximum, 20,000 years ago, global human population was somewhere between 100,000 and a few million people. They were scattered across ice-free refuges, southern Europe, parts of Africa, Southeast Asia, isolated pockets in the Americas. As the ice retreated, new territory opened. Coastlines previously buried under 120 meters of ocean emerged as sea levels rose. Land bridges that had connected continents for millennia were submerged. The flooding of the Bering Land Bridge between 11,000 and 7,000 years ago permanently separated the Americas from Asia. The flooding of Doggerland, the vast plain that once connected Britain to mainland Europe, happened around 8,000 years ago, creating the English Channel. These were not abstract geological events. These were catastrophes experienced by human populations. Coastal settlements were swallowed by the sea within living memory. Hunting grounds disappeared. Migration routes closed. The world humans had known for generations was physically restructured around them within lifetimes. And then something extraordinary happened. Within 2,000 years of the end of the Ice Age, humans in at least 5 separate locations independently invented agriculture. This is not a coincidence. The warming created new growing conditions. New plant species expanded into newly ice-free territory. The same orbital shift that ended the Ice Age also produced the stable, predictable climate that made farming viable. For 100,000 years of the Ice Age, climate had been violently unstable, swinging between warm and cold periods on timescales of decades. Farming requires predictability. You cannot plant a crop if you do not know what next season will bring. The stable climate of the current interglacial period, called the Holocene, is not the normal condition of Earth's climate. It is an unusually stable window. And that window is what made civilization possible. We did not build civilization despite the Ice Age ending, that we built civilization because of it. Now here is the part that changes how you see the present moment. The same Milankovitch cycles that ended the Ice Age are still running to be why the calculations of climatologists working with orbital mechanics, the current interglacial period, the Holocene, should naturally be ending within the next several thousand years. Without human intervention, the planet was already heading, very slowly, back toward another ice age. That trajectory has been interrupted. Since the Industrial Revolution, human activity has added carbon dioxide to the atmosphere at a rate with no geological precedent in the last 800,000 years of ice core record. The atmospheric CO2 concentration that helped end the last ice age, roughly 280 parts per million, has risen to over 420 parts per million. The feedback mechanisms that amplified the natural warming at the end of the Ice Age, carbon dioxide release, ice-albedo feedback, are the same mechanisms being activated now. The difference is speed. The natural transition out of the last Ice Age took 10,000 years. The carbon addition that has occurred since 1850 has happened in under 200. Milutin Milanković died in 1958, 17 years before the ice core data from Antarctica confirmed his theory was correct. He spent 30 years calculating, by hand, the orbital geometry of the Earth across hundreds of thousands of years to explain why the planet periodically froze and thawed without any external trigger. He was right. The Earth's climate is not a stable background condition. It is a dynamic system driven by orbital mathematics, amplified by ocean chemistry, and shaped by feedback loops that can run in either direction with consequences that restructure the entire planet. The Ice Age ended because the geometry of the solar system shifted by fractions of a degree. Everything that followed, the forests, the oceans, the farms, the cities, every civilization that has ever existed, emerged from that shift. We are not separate from the climate, but we are a product of it.